me, right? Great. So, I'm going to talk about, my name is Avi, I'm going to talk about how to design mobile apps for an offline. Let me introduce myself. So, I'm currently head of mobile team at Million Payments. Million Payments is a fintech company. We deal with payments between small businesses in the US. In my team, we've got an iOS team, we've got a backend team, and also an Android team. So I'm just waiting for your reaction about the Android, like the Flutter from before. Besides that, I worked 7 years at Anydo, which is a leading to-do list and calendar app, quite famous. I guess some of you know that. I've got 13 years experience of iOS since the iPhone 3GS, I think. And I'm also published 4 books. Currently working on my 5th. I want to start with some interesting quote. The internet was down for 10 minutes, so I went outside. The graphics were amazing, but the gameplay was terrible. And I think that's emphasized how much we are connected to the network, how much it's important, and we feel reliable when we have a stable internet connection. So what use cases are relevant for offline? So most people think about flying, because in flights we don't have an internet connection in most cases. And we usually consume content, mostly Netflix, TV Plus, Apple TV Plus. But we don't fly every day, right? I mean, a usual American flies something like 30 hours a year, something like that. And so why am I wasting your time with offline mode? I mean, only for 13 hours in a year. So let me tell you a story. This is story time. 4 years ago, I took my daughter to a birthday party. It was in the basement because it's raining. And if you look closer, this is me. And I'm not reading a book. I'm doing something much more useful. I'm opening Instagram, trying to spend the time, But the problem is that the router was on the 2nd floor, and the basement was not really having any 5G reception. So the reception of the Wi-Fi was almost there. So I was about 2 hours of trying to browse the network on my device. And, there is something that we expect the Wi-Fi to work, but it's not really working. You see that it's connected, but you cannot access the network. So it's not a Wi-Fi, it's more than a Li-Fi, okay? And a Li-Fi is really shitty, okay? Li-Fi is a problem, because when you don't have internet connection, it's very easy. You're just saying, no internet connection, please check your connection later. But when you've got a Li-Fi, it's a nightmare. And the next slide, if you're sensitive, please look aside, because the next slide is very terrible. We see this one, and this is a loader. This is a big loader, and we hate loaders. And why do we hate loaders? Because, I don't care about waiting 1 more second, but the problem is that I don't know what to expect now. I see the loader, maybe I will have some data in 1 second, 5 seconds, 20 seconds. Maybe it's going to be 30 seconds and then some timeout error. And users prefer and they want good experience. How do I know that? Well, there is a fake research I made up 4 months ago. No, don't laugh. This is a real, authentic, fake research. And it turned out that 100% of the users prefer good experience. And what do I mean when I say good experience? So good experience is usually performance. And when we say performance, we usually think about the A17 Bionic and Swift optimizations algorithm. This is something I generated. It's not a real quote, but it sounds like something that you would hear in an Apple event, with the A17 Bionic SoC and Swift optimization, working with harmony, experience a profound leap into the future. Okay, this is bullshit. I'm sorry. Why it's bullshit? Because the real bottleneck when you load the screen is the network. It's not really the CPU. And if we can remove the network, the bottleneck, then we have something really, really fast. How much fast? User will be able to use our app as fast as the speed of touch. So this is the ideal experience. And so when I say design an offline app, I usually actually mean design an offline first app. When we don't count on the network to have a stable connection, we just pretend it's optional, okay? We just use the app, and if we have a network, it's a bonus. So what's the agenda? So we are going to talk about some basic principles, and we move to data updates. We're going to talk about something we call optimistic UI updates, and we're going to finish with CRDT, which is it's a concept that is more suitable for distributed systems, but we can learn a lot about it when we design a mobile app for offline. So let's start with some basic principles. And if we want to design an app for an offline, that we need to understand why do we need a server. And there are a couple of reasons. Here are some of them. And the first one is we want to retrieve and update data. We want some centralized processing power. And we want to share some resources and collaborate with others. And I think that most times we need it for data. This is why we need a server to to get update and to add some more information. And if we remove the front cover of our device, we can see there is some component over there that we can store data. This is our drive. I'm not sure that this is the right location, but anyway, don't do it at home if you're not technical. And we can store everything there to support a better user experience. Well, you might say, oh, it's a cache, right? So there is a difference between a cache and a persistent store, because a cache is something that we use to avoid recalculations and to speed up the user experience or make some temporary storage. That's fine. But a persistent store is something much more organized. It's a structured data storage. It has some great capabilities. We can add more data and components and instances, and it's there to stay. So basically, a persistent store is a core data, okay, or Swift data or any other database. So if we want the persistent store to be always updated with our server, we need to talk about sync. And the bad news about syncing is hard. It's very, very complex. It's not complex only for us. Take a look at these screenshots for various and popular apps, how they behave when we don't have internet connection. Usually we don't see information because they had to sync it. But the good news is that we have the flexibility to choose how much we want to go deeper into the syncing algorithm. So we've got several levels that we can choose. We can go just offline first reading. We can just read, okay, not adding any new information. We can have some partial or full writing support. We also can add on top of it some real-time sync and collaboration, which makes everything much more complex, but it improves the user experience. So let's talk about Delta updates. Let's jump to Delta updates. You see, jump. It's the ball. And I think that the most important thing about offline reading and Delta updates is to make sure that our UI is consistent. When we see different screens in the app, we want it to be consistent across the app. For example, if I see the first screen here, I see 7 locations. I want to make sure that on the middle screen, when I drill in, I will see 7 locations, because right now I see 6. And why did it happen? Because it's a different endpoints. So when you enter the next screen, we need to wait for the endpoint to return so we can update the data. And this is something that users don't like, and you know that. We see that in apps. When you see some information here, you navigate, and then you need to wait for it to update, so your UI is not consistent when you go offline or you don't have any stable internet connection. And we have many endpoints. It's not only 3. right? So what do we do? So I tell you what we did at AnyDo, which I worked 7 years. We didn't have any endpoints. We had only one endpoint, which was a big sync endpoint. And when we have a big sync endpoint, we retrieve any update that we get for the server and then update our local DB. And when we do that, everything is consistent. Even if we don't have a stable internet connection, everything is consistent. How does it work? Well, let's say that we have a client and a DB, and we have 2 items on the DB. Then initially, we request some full sync. And then we return all the data. Then we save some timestamp locally on the client. The timestamp represents the most updated item. Then we want to get the new update items. We just send the timestamp to the server, and the server returns a new item. Yeah, that's there. So it's Michael, Scotty, and Dennis. By the way, these are Chicago Bulls old players, if you know, Michael Jordan, Scottie Pippen, and Dennis Rodman. And then we can save the new update every time a new player is added to the server. So Delta updates are great, but there are some things that we need to consider when we want to design and implement Delta updates. The first one is that the backend needs to maintain some timestamp for all the entities. And it sounds simple, but it's not, because sometimes an entity is related to another entity. So if you've got a list of items, and if you modify the item, maybe we need to update the timestamp of the list. We've got issue with some initial loading. I said that you need to load everything at the beginning, but what if you have too many items? You don't know what to do. So there are some things that you can do. For example, use pagination. You can load some of the stuff. You can change it to have some archived items and then load it lazy. And well, Delta updates are great and really increase the user experience. But I want to increase it even more, because there are many apps that are productive, and you need to create data offline and online. And then we have something that's called optimistic UI updates. Now, optimistic UI updates talk about how to add offline editing capabilities. And we call it optimistic UI updates. It's going to be OK. That's fine. We call it optimistic because we know that when we add something, we create the content offline, we don't need to worry. Whenever we get online back again, we can just sync everything to the server, and everything will be synced fluidly. That's why we call it optimistic. And we can perform any changes without waiting for the backend confirmation. If you know, for example, the Notes app on your app, when you type something, you don't need to wait for any confirmation for the backend. You don't care if you've got any internet connection, because it just works. So this is optimistic UI update, and we assume that everything is going to be OK. If, for example, we have some list of ingredients, then we add something offline. When we're back online, we just send the entities back to the server. But there are some things that we need to make sure. For example, if we create content offline, we need to take care of everything. It means that if we have a new list that's called work, and then we have 2 items that belongs to work, we need to establish all the relationships offline. We also need to create some unique IDs for the elements offline, because we're going to sync it to the server. The item created offline on the client, so we need to generate it myself. And there is also thing that called validation. If we create something offline and then we need to sync it to the server later, that we need to make sure that it passes any validation rules. And if something changes on the server, maybe we need to share some documents of validation rules with the server. So it's not that simple. But wait. It gets even worse, because now we have sync conflicts, right? Because we have 2 devices. We have maybe iOS and iPad, the Vision Pro, the lucky of you next year. And when we create a data offline, and then we sync it with another device, maybe we can have a sync conflict. What is a sync conflict? So let's say that the server has an item, which is a dog, in this example, and then we sync it to both devices. Then the first device changes it to a cow, and the second device changes it to a cat. And then they both go online. The first one is device A, so it changed the item on the server to a cow, but then goes the second one, and it changes it to a cat. And then that's it. This is called a sync conflict, because the backend receives an outdated version. So there are two popular ways to deal with it. And I guess that you know what it means. The first one is last write wins. The server pick the most updated, the latest version. And the second one is the first write wins, when the server rejects the new version that it gets. Now, if you're lucky, you can try to merge stuff. For example, if you get two versions from different clients, maybe we can, I don't know, we can take we can do some diff and take the updated property from one device and the second one from the other device. But this also has issues, because we don't know if the reason that we don't have any change is because nothing happened, or maybe we change it and roll it back. So in this case, maybe we need to maintain some updated timestamp for every field. And this is something that we did in AnyDo, because we had to do that. And optimistic UI updates are really amazing in terms of user experience. And they are very good for single user environment. They are good for non-collaborative editing, because once you have different users, it becomes really messy. And it's really good when the low update is rate. So that was optimistic UI updates. Now let's talk about the problem that it holds and how CRDT can partially solve some of the problems. So we have issues with optimistic UI update and just writing capabilities. And this is one example that can happen. You know Medium, right? The Medium, the blog site. So Medium has something that's called claps, which is similar to likes and Facebook. But the change is that you can, as a user, give more likes, more claps than one in one day. You can give up to 50 claps a day. And if you have two devices and you working with Medium and you want to do one additional clap on second devices, so you gave one clap on device A and another clap on device B. Then when you sync it to the server, you expect to see 3, because you give one clap in each device. But the problem is that the server needs to pick one version, which is obviously going to be 2, because 2 versions are true. And this is just one example. For example, if we want to update some list that's represented by array. So we've got one list on device A, we add orange. And the second device, we add mango. And then we want to sync it to the server to have something like apple, banana, orange, and mango. And we need to pick one version, so we get rid of the mango. And text editing is even worse, because we lose words that we type. For example, if we say hello Paris in device A and hello Smiley on device B, we want to see hello Paris and Smiley, but we need to give up Paris, and we like Paris, right? So we can't give up Paris. And the reason that it happens is because we are syncing entities to our servers. We create or modify the entities offline, and then we sync it to the server. And that causes issue, because the server receives 2 entities that collide, and it doesn't know what to do with it. So that's why we have something that's called CRDT. Now, CRDT is it's not something that comes from the mobile world, but rather from the distributed system world, when we have different systems with replicated databases, and we want to sync all the databases without even needing a server for that. And CRDT works, instead of sending entities or instances, we send messages about the change. For example, instead of sending the list of fruits, we just send a message, add a mango to the list. And instead of sending the number of claps, we just send a message, increase the counter by 1, or add string pairs to index 6. And CRDT has two rules. The first one is we don't care about the order of the messages. We can send the messages in different order. And remember that because we're going to have an issue in short. And the second is that we can send duplicate messages and it's going to be fine. It needs to be very, very stable. So all the clients and all the databases are going to be replicated exactly. This is an example when we have 4 devices. It's 4 people, actually, and device D is offline. And then device A has a change. Fill cell number 5 with blue. Then it's sent it to the backend. So we got one message. And device B retrieved the message, and it can update it. And then device B fill cell number 9 with green, and then he sent it to the server, and A and C, are being updated. Then device D is back online, he reads the messages, and we can apply it to its database. Now, working with CRDT is not just changing from entities to messages. It's much more than that. It's a really different mindset. Because when we work with that, we need to be very, very consistent between the replicated databases. When the user, for example, adds some item in its user interface, we don't just insert a new item to the database. We create a message, and then we apply it to our own database. We apply the message. And the reason we do that is because we want to have the same behavior when we get a message from the backend or when we create it from the user interface. We want it to be the same every time. Then we created the message, we save it locally, so we need to think how to do that. It's not a business logic entity, right? It's just for syncing. And then we need to ship it to the server. So, okay, we get it. I mean, do we still have conflicts? What do you think? Of course we do. Otherwise, I won't ask that question. So, even CRDT is not perfect. And let me show you one example. And it really depends, this example really depends on the algorithm that you use for CRDT, because CRDT has something like 8 or 9 popular algorithms. But let's say that we have 2 devices with the word hello, and then we add hello universe on one device, and hello world on the second device. And then we sync it to the server, and we expect to see something like hello universe world, or hello world universe. It depends on the algorithm, but you can choose whatever you want by alphabetically or not. But instead of that, you get something like hello world. Never mind, you know what I mean. It's not something that we can read, and the user gets it, and then he needs to delete it and write it again, and it's not something that the user will like. And the reason why it happens is because when we work with syncing text, for example, that we use boundaries of 0 and 1, because we want the flexibility to insert characters between other characters. So we use some friction values to do that. And then we had 2 devices with the same friction values. Everything goes fine unless we add some more data, more text. So on one device we added universe, and the second device we add world, but it's different lengths, so we get different friction values because we need to generate some values. And then we sync it and we try to reorder the letters, and this is what happened. Now, you may say, okay, this is something that won't get to production, right? So Google Docs had this bug many years ago. Of course, they fixed it. And this is something that can happen with just messaging. What else? Let's say that we reordering items. So if you remember, we said that there are 2 rules for CRDT. The first one is that we don't care about the order of the messages. But we don't have a move operation on CRDT. So what do? We create 2 messages. It's delete and insert. But since we don't have any order restricted, we can set it with whatever order that we want. So what can happen is that we can delete twice and then insert twice, and we get duplications. And I think that the last example is maybe the most fun. We've got, I don't know if you can call fun for sync issues, but let's go for it. We've got two devices with some hierarchy of employees. And in the first one, or the left one, we did a change. We moved Alice to be under Tom. Tom is the manager of Alice, which is, I mean, this is a valid operation, right? And on the second one, we moved Bob to be under Alice. Now, what will happen when we sync it? So Alice is the manager of Bob, which is the manager of Tom, which is the manager of Alice, which is the manager of Bob. So we've got a cycle. And it happens even when two operations were valid. And I think that emphasizes how much complex syncing is when we try to do it offline. Now, let's have some summary of what we talked. There's something they call Li-Fi. Okay, now that you know that. We talked about some offline reading. We talked about optimistic UI updates. We talked about conflict resolution. We talked about CRDT basic and some edge cases. And there's one note that I hear every time I speak about offline that I want to tell you. We've got a great solution today for offline. We've got Firebase that can sync everything. You don't need to do anything of that. I'm not saying that you need. We've got CloudKit that can do many stuff for us. And well, there is a reason why I'm talking about it, even though you don't need to do anything of that. I don't see you because of the lot, but please raise your hand, developers that are more than 9 or 10 years developing iOS. Oh, okay. I'm in a good company. So, yeah, if you remember, 10 years ago, everything was much more complicated, right? We had, instead of core data, we used SQLite, I remember that. And then we moved to core data, and now we have Swift data, which is much more useful and much more simple. And we had to animate using commit animations before we had the blocks. Actually, we didn't have blocks on the days of Objective-C at the beginning. And everything was much complicated. Now we have dozens of tools that can help us, the framework that can help us produce much more useful and effective code. And everything is much simpler, which is great. We need to continue with this direction. But there is a price for that. And the price is that we are starting to get away from the basics, from the infrastructure. And I think that if we want to be better developers, better programmers, better iOS developers, we need to understand how things are working underneath. We need to understand what are the challenges, because when we know more, we're going to be much better in solving new issues and new problems. So thank you for listening. That's for start. Now, so this is a QR code for a feedback for my talk, and is a little surprise. I will pick randomly 3 people who answered the feedback, and they're going to get a print copy of my latest book, the Complete iOS Interview Guide. So I encourage you to answer the feedback and maybe get a present from this conference. Thank you.
Thank you, Avi. One quick question I had to start with. I started working on mobile things a long time ago.
About what?
About mobile things, mobile apps a long time ago. And we already had, before the iPhone, on PDAs, things like that. We already had synchronization issues, offline issues. Why is it still such a complicated topic nowadays?
Well, because nothing has changed, you know. I mean, we're still syncing issues. By the way, if you remember, iCloud was a nightmare a few years ago in syncing issues. It just got stuck. And we had issues at AnyDo when we synced many data, and it was without even the CRDT. It just regular data. And the problem with syncing is that small things can just break your sync. It can bring you to a state where nothing is happening, and it's very easy And very difficult to test it because you've got so many edge cases. You saw here, there was edge cases that I didn't give you an answer because the talk is too short for that. But if you Google in YouTube CRDT, you will find stuff that are really, really complex, and every small issue can just break your sync. It's not that a small data is not syncing, it just stop the sync. That's the problem.
Okay. From what I get, you said there are many implementation of CRDT, and from what I get, the kind of issue you might run into really depends on how you interpret the difference that are applied, and so in the end, isn't it related to the core of your application? And so my question is there a possibility to have like a library that is generic enough? Or do you, if you need to implement CRDT, are you doomed to go from scratch?
So I just said that there are libraries for that. The most famous, I think, it's Firebase. It does that for us. A CloudKit you can use. I don't know, but someone told me that you can use Git for that. But Git is not suitable for text editing. So I don't know if someone can tell. I don't know if there is a library that can solve text editing issues between devices. But for all the others, you can use Firebase and CloudKit flawlessly.
We'll take a question from the audience, from Simon, actually. Are there any cases of apps that should not adopt an offline-first approach? Should not.
Should not. Yeah, so I already said that in Anydo we did that, but in my company, I work in a fintech company, and it's payments. So it's very, very hard to do a payment when we're not online, so you can't do that. So, and payments, it's also some regulations and legal issues that you can't do because you are not online, and we've got some engines that check. So I think that fintech world is a problem. By the way, not only for payments but also for retrieving data. So I think that things that are sensitive, like crypto and fintech, stuff like that, are problem in offline mode. So we need to be more careful over there.
Do you have a last question?
So the question that's wondering, how can you convince your backend team to move away from Rust and towards CRDT? And so the question is also, how much work should you plan when you need to move from one way of working towards the other?
So the question is from REST to CRDT. Oh, you talk about optimistic URL updates, actually.
Yeah.
When you say go to that. So one of the best things about moving to optimistic URL update is when you get rid of many endpoints because you have one endpoint. And this is very, very... Okay, so it's decoupled the work between the client and the backend. This is what happens because you don't need, as a client, the backend for every small task. You can just generate and change everything on the client and then sync the stuff to the server, and the server doesn't need to know about it. On the other hand, it requires more work from the backend side to set up everything at the beginning. But I guess it's much more fast after you do that, both for the backend and the client.
Thank you, Avi.
Thank you.